in finance and also within community work. And then we're going to do a short demo. We're going to use code. I'll be writing code, everyone will be watching me write code, but we're going to use Python. It's a programming language to read all of Shakespeare's work in just a matter of minutes. And then after that, I'm going to just talk a little bit about the age of AI and how COVID has affected it and what we can expect to see in the future of work. And then I'll talk about the programs that Work Code has to offer. And yeah, that would be it for the session. And then I'll start taking questions from people who have like numerous questions, and then we can call it a day. Okay. So the overview of computer science. So mostly computer science is very difficult to define first, because most people, when they see computer science, then they just think of the word like, oh, that's a computer. But then computer science is not just the study of computers, but computer studies is the study of computers. But computer science started back in the day when we didn't even have computers. So computers right now, they just play a very important role in supporting our work when we try to like learn more about, when we try to solve problems using the methods that we get from studying computer science. So, okay, I have to go back. So computer science is the study of problems, problem solving, and the solutions that come up through that problem solving process. So basically what a computer scientist does is you have a goal and you have a problem, and then you try to come up with a step-by-step solution. So those are instructions, for example, that you might use to solve a particular problem. For example, if I ask you to solve a quadratic equation, your step-by-step instructions are basically how you describe how someone might actually calculate how to solve a quadratic equation. So what we do as computer scientists, for example, is just we have numerous problems, you know, maybe it can be counting problems, or just so many are within the field, so we get to study them. But then now when we've found an algorithm, when we've found a solution, then we'll need to use programming, that's code, to really clarify the step-by-step list of instructions that we can use to solve, to express our solution in a way that a computer might run so as to scale the impact of our work. So most people right now, they use computers to like write documents, send an email, watch something on Netflix, play games. But then when they use that, there's this idea of abstraction, more of like a separation. You can use a computer without really knowing how, you know, how the computer like functions. You can like write and send an email. You don't have to worry about, you can like a picture on Facebook, you can send someone a DM, you can watch a video on YouTube, but you don't really have to worry about the details or the knowledge of how those applications are working. So we say that most people who use that, they view it from a logical or a user perspective. So for most people, when they now think of computer science, they might try to use this definition of defining computer studies as, oh, computer science, I might be, you know, like playing a game, or I might be doing something, or like, but then for us as computer scientists, it's just like, we have so many problems, most of them they involve mathematics, and then we just get to solve those problems, maybe on a piece of paper, and then we can just take those step-by-step instructions and just write them on a machine and execute them. So computer scientists and programmers, they take a different view than a general user. So for them, they have to really know how operating systems work. For example, your Windows 7, Windows XP, Windows 95, those are as old as I am. And maybe can be Ubuntu, Linux, and they also have to know, for example, when it comes to, we use Instagram, we use Facebook, we use Twitter, but computer scientists, they have to know how all those network protocols are configured and how different scripts or different parts of code or different sets of instructions are grouped together, or how they follow each other in a way that they can control the function or how things should be. So these are low-level details, and this is most like the job of a computer scientist. So for most people, when they now look at this, they then say, okay, this is hard. There's no need for me to learn code. But today I'm here to tell you that programming is something which is at least different compared to that. I think so. I'm giving an overview of programming. So programming is the process of, so when a computer scientist finishes, for example, solving a problem on a piece of paper, they write step-by-step instructions on how they solve that problem. Then what a programmer will then do is to then take an algorithm, which is a solution, and then encode it in some notation. So that notation, for example, we can call it a programming language. So what you can think of is you can basically think of having someone who can, for example, come up with a sketch, maybe an artist, maybe like someone who just comes with a sketch and just write something on paper. Think of someone maybe at school with a very, very terrible handwriting. They can just write something on paper, and then they'll then give someone, who has a much prettier handwriting to then take it and like actually write it in a way, that can be like more prettier and like more effective. So I think with computer science, they are all interested, they are just interested in just solving problems and finding solutions. But then what a programmer does, they take the solutions which are already there. Remember, we say that an algorithm is a solution, and then they just encode it into some sort of annotation. So when they take that notation, they write it in a file, and then they can click on something, and then the computer will know how to execute or to interpret that file. So there are so many different programming languages. I'm going to talk about Python today. But before you even sit down, before you open a laptop to say, okay, I want to write code, it's always important that you first need to have a solution. So without a solution to a particular program, then you don't have that algorithm. So you can't write any type of program. There's nothing to write. This. So now I spoke about computer science and programming. Now there's this new field which is coming up, which is data science. So right now, over the past 10 years, for most people, for example, in Zimbabwe or any other parts of the world, if you think back maybe 20 or 15 years ago, when we're all still maybe using Nokia 3310, no one would take selfies, we didn't have that. We're not searching for so many things on YouTube. We really didn't have these devices. But right now, over the past 10 years or over the past 12 years, so much has happened in terms of technology. Right now, we have very fast and powerful devices like in our hand. So every time when you take a picture, or every time when you send a message to another person, or every time when you do something online, what happens is you generate data. So from this data, almost like in the last 2 years alone, 90% of the world's data has been created. So if you look through the history of time, and then you look at all the images, that have been taken, all the paintings and all. If you look at the images that people took the last 2 years, those represent 90% of all the images that have been taken in all of humanity. So if we then look at this data, we now have some sort of a gold mine. So the importance of data is we can learn so many things from it. Uh, if I know that, okay, I have my students, they go to Facebook and they get to like, maybe they can like a certain post. If I see that, okay, this post has a higher number of likes, then I might know, okay, people probably like prefer this post. So just to give an example, there's an Instagram account called Royal Memes. So when the owners of the account, when they make a post, sometimes you can see that there are 1,000 likes, there are 5,000 likes. So what happens is every time when someone likes a post or likes a video, we get data, and from that data we can actually like learn so much, and we can use that to come up with decisions that, for example, it can improve maybe in terms of advertising, in terms of targeting people with what they want, and we can also use that data to improve for health and also to improve on education. So um, so data science is this concept where, because over the past 10 years, we've been producing so much data. So now with big data, we have to find a way of, just cleaning the data, analyzing it. So data scientists, they get to understand and draw like some accurate insights and predictions, that they can use to make really good business decisions. So how data scientists work is they apply maybe like machine learning or sentiment analysis or deep learning to find useful information from the data. So these techniques, they help data scientists, for example, forecast the future based on like some patterns or similarities. So right now, maybe just to get people thinking, over the past couple of years, you have been using Facebook for free. Uh, you don't pay for it, but like, why would someone make you use a product for free when you're not paying for it? So what happens is every time when you use Facebook, every time when you make a connection with another person, every time when you like a picture, when you post something, you generate data. And so what people at Facebook do, or what people who write code do, they use all these models, maybe like machine learning, predictive analysis. So if you don't know more about this, don't worry. Like by the end of this discussion, I'll have exposed most of you to these terms. So when they get, for example, like they can look at the data. Let's say there's a trending hashtag in Zim, and people get to like that hashtag, or people get to like some posts. So they can see, they can target ads, and businesses can pay so much money just to target you, maybe to sell you, the latest iPhone or the latest shoe or whatever that might be there. So this is a diagram. I call it the Data Science Venn diagram. So it tries to combine the knowledge. For most people, especially maybe you're in high school or you are at a university in Zim or elsewhere in the world. So what you might have been doing is, like in high school, they teach us so much math or maybe statistics, something about probability. And then in your own field, you might be in literature, in philosophy, in economics, in business. You fall under this category for the this domain emphasis, the expertise category. So what the purpose of this talk is to then get you to also know some of the hacking skills. Because right now, before, if, for people who don't know how to code, they are only limited if they're using math and they're using their knowledge. For example, someone has some knowledge in epidemiology or some knowledge in public health. What they can only do is, what I call traditional research. But then they can only do so much to a certain portion of data. But because over the past 10 years, we've been collecting large and large amounts of data. So then we now need to put these hacking skills. By hacking, I mean coding skills and programming skills, not infecting someone's privacy. So we need to include these hacking skills and combine so that we can reach this center where we can now start talking about about data science. So data science is you're using your mathematics, you're using your knowledge of maybe geography, economics, or whatever field that you are good at. And then now you combine it with some knowledge of writing code. And then you can then apply some machine learning models on data and then use that to make a decision, for example, to choose whether people can buy a product or to choose whether you can to choose on the different strategies of intervening in a given social system. So yeah, this is just a diagram which shows that there are so many different parts. For example, you have statistics, you have neural computing, machine learning, and all of that. It just shows that data science now is very difficult to, for example, separate a field and say, oh, these are commercials, these are arts, and these are sciences. So all of them, they are all intertwined in this web. And with coding, with math, and all of that, it helps you to neatly collect them together so that we can form this beautiful sphere of data science. Okay. So I can just give maybe a brief talk about how people use programming or how people use coding in public health. So like today, so many technologies are there that generate large amounts of data. So I see most of my students, I see most of my friends, they are fitness enthusiasts, and every time maybe someone has an Apple Watch or they have the Nike app on their phone and they can get to run and share something on their Facebook page. Those applications, for example, those technologies, they're able to collect information, like they can collect your heart rate, they can collect your breathing. So even in, if you go to a hospital, they can now use technology to really monitor how people work or how people behave. So because these technologies, they are now also gathering large amounts of data. So now we can also start using techniques like machine learning uh, and other data science techniques to gather insights from this data. So for example, when like Nike, when people download the app and then you run on it, they can get to they can get to calculate, for example, how many calories do you lose, over a given period of time, how much weight did you lose, or they can also check trends. If you share your runs with someone else, your friends, they can maybe also have a way of comparing that data. And also, maybe let's say you are running. I was talking to another friend who had a shoe which is somehow connected to an app. So as you run, that shoe has some data which it sends to the phone. So now, because of this kind of technology, as your shoe or your watch, as it gets to collect data, then people that are able to then, business leaders, they now have to rely on code to try to understand basically like how how to target, for example, maybe let's say how to improve uh, the next shoe. Maybe they're like, oh, people, they are not comfortable. Like right now, this current shoe, if someone runs for 2 miles, they get tired. If they run for 5 kilometers, they get tired. So how can we redesign this shoe so that people can run longer? So now, because there's large amounts of data, people before, they had their domain expertise, maybe in business, and some they knew mathematics, they could do statistics, but they now need the power of code so that they can really scale up whatever solution they had on like large data sets. So remember that the reason why you want to learn code is most of the jobs right now which you want to apply for, they will be handling large amounts of data. Okay. So for these technologies, for example, now we really need a collaboration between public health and technology. So I just described right now, for example, let's take a look at the COVID pandemic, how we can use programming to really understand, for example, in our situation with COVID. So let's say you have a city that's on lockdown. So you can write code to figure out, the number of cases, maybe in Bulawayo, the number of cases in Harare, or the number of dates. And then you can also plot graphs and compare that with making some minor changes. For example, you vaccinate some people and then you see how that behaves. So by using code, you can run simulations to basically predict, how to vaccinate people, to predict how to put a city on lockdown, to predict, and also how to open up economies. So over the past year, like, governments have been relying so much on data, and they've been relying on people who know how to code to help them come up with these solutions, to whatever problem they might be trying to solve. So for mostly, they use statistical modeling, and also they can also use code to build apps, and some other like electronic devices that they might need, and to also just create a database so that if you go to one hospital, they don't have to write your medical stuff on a piece of paper. They can always, like log in and access it online, and that way, your information can be transferred easily between two hospitals. And then I have an example of how programming is in finance and business. So in finance, I was reading, when people signed up for this, there are people asked, how they can use programming in finance. So programming is very useful, like more in a variety of situations. For example, when you want to calculate, uh, when you want to set up electronic trading systems, or you want to manage systems, or you want to calculate some investments, or take some pricing derivatives, all of that you can do most of the calculations faster if you are using or you are relying on code. So what one programming language which is the most growing language right now in finance and business is Python. So, people, they use Python for pricing, for risk management, and also to build up some platforms and dashboards that they can use to visualize data. So if you would want to work maybe at an investment bank or some hedge funds, one of the days it's always good to pick up some skills in programming. Python also helps. For example, there are some there are some, in the past, we could we could do some calculations using Excel spreadsheets. But right now, since you might want to calculate data, and you have like millions or like hundreds of millions of rows, then it now becomes slower, maybe for example, to do some of the things using Excel. So now if you know how to code, uh, code helps you like create like analytic tools and models, and it also helps you just do your task much faster and with greater efficiency. So Python is big. Python is big. Some business schools, I know there are grad schools, there are grad students who might be here. Some business schools have already started teaching MBA students how to utilize coding for data analysis and automation purposes. And what I like about Python, that's also the programming language which I first used to introduce people. It's you can write fewer lines of code than any other language, but then you can solve like more complex problems, and it's also like easier to learn. So another example, someone asked this, so I just put this example just the last minute. So if we look at actuarial science, they yeah, if we look at actuarial science, there there are two primary reasons why actuaries need to know how to code. So I know maybe there are people at NAST or white, some other institutions. You already have a curriculum which is like more intense on math. But so the first reason is like there's always you're always dealing with data. For example, if you're in the field of actuarial science, so actuarial scientists, they are people who calculate risk. Maybe in businesses they have to, maybe like let's say in Yarad, so it's a funeral parlor. People they'll come and claim, that maybe claim insurance or all those things. So they need to have actual scientists who will be able to, learn from the data so that they can make well-informed decisions on their policies. So let's say you are given a project, and you have 10 pieces of data for each policy holder. Let's say it's Narado, and then for each policy holder, I'll be talking about a member. So let's say you have 10 pieces of data. You can be tracking someone's name, first name, last name, date of birth, phone number, address. So all these are different things. Maybe you can also like add next of kin, where they work, or like if there's also some like medical record, you can also include that. So now when you have that data and you want to like analyze that data to get some useful information, if let's say you have 100,000 members or policy holders with 10 to 100 pieces of data. So already, like if you look at this number, if you multiply this by 100, now you have like millions and millions pieces of data. So it's difficult to really work with this if you're in Excel. So that's why most actual scientists right now, they are switching to using code, because you can actually like do your calculations much faster and much easier by relying on programming. And then the second reason why they use code is to automate some of the tasks which are recurring. For example, if you already know that to calculate something, you need to multiply X and Y. Okay, so it's better to write a set of instructions that we call code that will always tell you or tell the computer to do this. So let's say you know that if you are calculating like maybe some reserves, and then you have to calculate them every month or every quarter or every year, or maybe like every week, or you're an accountant, you have to balance your stock, or you have to balance your accounts, or do the trading profit and loss, and yeah, all of those things. So if you try to do it manually, you take so much time. But then if you know how to code, you can basically look at how you do it manually and then come up with a set of rules that we call code to really save you more time. So the next time, for example, you can now build it maybe into a web app. The next time, what you just have to do is to just click a button and just the code will, those set of rules which you defined, they'll do some magic on the data, and then you can just review it to see if it's reasonable. So this saves so much time, and it allows, the actuary, for example, this person who analyzes risk, to meet strict deadlines, to reduce mistakes, and it also just gives, someone more practice. And it just ensures that, the results of your work are reasonable. So companies right now, because the companies are always after profits, so they'll rather choose to hire someone who knows how to code. They'll rather choose to hire someone who can do the process faster, than to get someone who will then take, like a week to do something which another person can complete within 2 hours. So I think this one would be more interesting to most people, like, just know what does programming, how does programming help you within your community? So because of COVID, we've been pushed actually over the past year to go towards digital transformation. So right now, for example, physical contact is so limited. So if you check on Facebook, churches and schools, they now need websites and mobile applications to keep people together. So if before, you used to go to church and you sit down and like, you uh, talk with your fellow church members, or you used to go to school, you could sit or you could study. In 2019, when I taught the first course, I taught my students in person, but right now we have to use Zoom, so we're forced to go digital. So knowing, for example, how to assemble course websites can help teachers to deliver like more materials. So like learning how to code is not only for like students, but also for teachers, if they really want to be more creative in their work, in their content delivery, they can, just put some time and some hours, just learn how to code, then they can use that knowledge to scale up the solution or the impact of their work. In that case, it will be teaching. So churches, for example, maybe let's say you're passionate about your ministry and you already know how to code, you can use that to build a website. And right now, most people, they set up online stores. Maybe someone has uh, a YouTube channel and then they want to create their own website so that that website will connect an Instagram page or a Facebook account. Or maybe let's say someone is an artist, you have your music, or maybe let's say you're a poet, you write your stuff. So most of the time, like, you'd want to do something, you'd want to learn how to code so that you can just build your website and showcase your work. It's either you have two options. It's either you pay people, and right now to pay people who can do the work for you is really, really, really expensive. So for an average, for example, in Zimbabwe, to build a simple mobile application, it costs about 4,000 US dollars if you are really charging someone like within like not a reasonable time. And for most people, they don't have that money. So if you are working on your organization or on your nonprofit, or you and your classmates, maybe it's Toastmasters or it's a club at school, and you want to have a website, you can't afford to hire someone right now because the cost might be too high. And it's also like very hard to find people who can actually build the work and carry out your vision the way in which you want to be. So if you like take the time, learn how to code, even for people who want to, have your own startup at some point, your startup will move faster if you can do most of the work yourself. So yeah, I'm going to do a demo. So in this demo, we are going to read some work from Shakespeare. So I have, this is a program, this is called a terminal. I think, yeah, I think people can see my screen. So what I have here, I can open this folder. There is a file called shakespeare.txt. I'm going to open it. Let me open it in a friendlier way. I'm going to open it using a program called Sublime Text. So what I have here is I have all of Shakespeare's work. So for people who like literature, I love literature. So this is all the work that Shakespeare wrote in here. Like, so all of Shakespeare's books, someone copied them and put them in this one file. So if we look, for example, I can scroll to the bottom, you know, this file already has 129,000 yeah, something lines. So, you know, that's so much work I wish Shakespeare got to read. So if you'd want to, for example, like sit down, maybe there's some information which you really want to get out of Shakespeare's work. If you try to, maybe let's say, I might ask you, how many times did Shakespeare use a certain word? So if you try to open like Shakespeare's 20 or 50 something novels and actually read line by line, and you can try to locate all those words and count them, you can do that, you know, for your entire life. And, you know, you might not even finish it. But with the power of technology, with the power of code, we can be able to do this just within minutes. So I'm just going to do a demo. So let me scroll up so that you can see this. So what I have right here. So the code, if you don't know what's happening, which I think most people want, don't worry. This is just an info session to get you to love code or to be curious. So what I have is I can see that in this folder, I have this file called shake.txt. Let me increase, okay, yes. So now what I want to do is I want to run Python 3. So now I'll be running code in Python, okay? So what I'm going to do, for example, in this case is I want to open this file in Python, then I'll get to read it and I'll get to analyze it. So there's this keyword, this rule which I can use. You know, I can say open the name of the file. So I can say open shakespeare.txt, you know, and then I can just close it like this. So you can see, for example, this shakespeare.txt, there it is over there. So now if I click this, then I can say, okay, now let me just read, you know, like, yeah, let me read the text, and no, let me just okay, since I've opened the file, you know, it's always good to, like, you know, to read this file, okay. Okay, but then, oh, if I read this file, you know, I'm just going to get like all the words. I'm like, okay, let me just split it into words. So I'm going to read it, and then I'm going to split it. Okay. So now I can then check, you know, what's the length of all, you know, the words in Shakespeare. So if I try to check, okay, the length of text, and then, oh, I find that Shakespeare the mighty Shakespeare didn't even write 1,000,000 words. 1,000,000 words, all his novels, we sing of his praises, but he just falls short of 1,000,000 words by just a mere, like just less than 20,000. So there's so much which I can do, I've just opened this file. I'm trying to get more data, to understand more of Shakespeare's work. So what I can also do, for example, I can say, okay, show me the first 25 words. So now I can just, see, okay, a midnight summer stream, now fair, Hippolyta, our something, something. And then if you look at this, we can basically see that, oh, these are the first 25 words, of Shakespeare. It ends, okay. So these are the first 25 words. So now I was able to read parts of the file, parts of the Shakespeare file, and then just put it in there. And now I can even do more. For example, I can count the number of times that Shakespeare wrote, maybe let's say, how many times did Shakespeare write the word "the"? Okay, so from this entire file, Shakespeare used the word "the" 23,000 times. Okay, this guy even serious. Most of his right. Okay, let's check how many times did he use the word thou. Shakespeare and his, like, that language which you find from the Bible, like the King James Version Bible. So yeah, he used the word thou, almost 5,000 times. You can also check, for example, what does thou mean? Let's check how many times did Shakespeare use the word maybe you. Okay, that's an interesting one. Yeah, see, yeah, Shakespeare used the word you like 12,000 times. But there's this other interesting word which Shakespeare used is called fusut. I don't even know what that means, but it turns out that Shakespeare used this word for 40 times. But then since how I split the words, I can also say, wait, how many times did Shakespeare actually use the comma? And then now I can say, oh, actually Shakespeare used this comma 81,000 times. Then now I can actually calculate the percentage, for example, of the words, Shakespeare's words that are like, because I know that all his words, including the comma, we had like 980,000, but now I know that he used the comma 81,000 times. I can just try to find the percentage. So the percentage, we know that is finding the length and then also multiplying by what? By 100. So it's 100 times. Then you can say, okay, so you want to find, for example, the proportion now as a percentage. You're like 8% of Shakespeare's work was just using the comma. So now by just like, we just in this short space of time, we're able to, for example, just use, Python to like get to like understand some interesting information in Shakespeare's work. Now I can, for example, let me scroll something here. Let's find the number, for example, of unique words that Shakespeare wrote, because we know that some of the words, they might have repetitions. So I just put them into a set. We all know from Form 1 mathematics, when you're learning sets, that all elements in the set, they have to be unique. So now you can put all the words in a set, then you know that double unique. So if you just find the length of words, then we know that of these almost 1,000,000 words, he was just using, 33,000 unique words. So we can find, for example, okay, what's the max of the words? Okay, if we say, what's Shakespeare's longest word? So when we say longest word, we get, wait, this word, it's a swagard or like swagard. I don't know what that means, but it actually turns out that it gives you the last marks will give you like the last like the last word sorted alphabetically. So now if we really want to find the longest word, you can just play around with Python and then just like put some key and say, okay, sort on length. And then this from Shakespeare's entire work, this is what? This is the longest. This is the longest word. Okay, so I think that's what I had to show, for example, to demo with Shakespeare. So I just going to continue. We're about to close and then I'll take questions to continue with my slides and yeah. Okay. So yeah, so this is Shakespeare. We got like this COVID edition of Shakespeare because of we have to wear masks and all of that. So the age of artificial intelligence. So I was reading a paper uh, from McKinsey. It was published like last year in September. So I was looking. So they got they sent like a survey to like 800 executive members, and they were just asking them how the pandemic, how the COVID-19 pandemic is actually disrupting work. So this is an interesting study because from looking at this, we can actually see that the pandemic is going to affect most of our lives. And over the next couple of years, over the next couple of 10 years, most of the jobs, they are moving towards automation. They are moving towards digitalization. There's an increase in the demand for contract or gig workers, for example, freelance workers. Right now, everyone is trying to move online. They'll need people to help build their websites, build their mobile applications. So they'll need to outsource for that kind of talent. So if we look at this, for example, we can see that 67% of some of the companies in this 800 study, they're actually adopting automation and artificial intelligence to use them in their work. So the times at which we are right now, there are times which require, almost everyone, young people, to learn how to code. I have my nephew. He's in grade 2. I've already started teaching him how to code. So share the word, get so many people to join us in learning how to code. So about, I think people might be wondering, how they can also get to learn how to code. So I found that when people try to go online or to watch YouTube videos on their own, sometimes there is this illusion that someone is doing something, yet they might not be doing as much, as they could take. For example, you might go on YouTube and try to do a course on your own. Then you might actually find that you are not being thorough. You don't have a push. So Mzinwe Code is there to help you get started in learning how to code. So what we have is we have this introduction to programming class. So in this class, it's going to start the last week of April, and it's going to go on for 8 weeks. So this is an introduction to computer science, and we'll be just teaching you how to structure and interpret computer programs from a programmer's point of view. So don't care more about what this like hard English is saying. It's just like to make my slides beautiful. But then in CS7, we're interested in just to get to teach you more about programming. We don't say that we're teaching you how to use Python. What we are teaching you is how to think and how to understand programming languages. So at the end of taking the course, as a side effect, you would have mastered how to use the Python programming language. And when you want to move on maybe to another language like Java, JavaScript, and all different frameworks, you actually find that it takes a matter of hours or days to learn a new language. Like right now, if someone were to create a new programming language today, and then because when I was trying to learn how to code on my own, I really took time to understand the fundamentals. So you know, it would just take a matter of hours or just a matter of days for me to get a working knowledge of a programming language. So the class, we're going to release registration. You can check us on our social media. Follow us on Twitter. It ends in Record up there, or that's when we're going to announce that people can start registering for the class. So what really targeting, if you just finished your A levels, you have that time, use this time to learn how to code before you even go to university. If you're a university student, I even invite very, very curious, and interesting Form ones. If you have a Form 1 and you're really passionate and you also love math, I can also invite you to join uh, to take uh, the class with us. So for the 8 weeks of the course, people are going to have three large computer science projects, which are more AI driven. So you can be building a game or building strategies, really deciding how the game should win. And also there are like homeworks to help you think and solve most of the challenging problems. And then we have lab sessions to get you started in learning how to code. So for this year's class, we are going to have an exam. There won't be, one like it won't destroy you with the exams, but we just want to like push people to learn more. So there'll be one midterm, just like halfway through the course, there'll be an exam, and also towards the end of the course, there'll be another exam. So this year, how we are teaching the students is, even if you don't have a laptop, but you have your phone, you can access WhatsApp, you can go on the internet and access my course websites to like get to learn, to access the coding material. We have been designing this course in a way that every student can complete their assignment on a piece of paper. So you can write your code on a piece of paper, and then you can submit it to us. We can grade the code on a piece of, which you wrote on a piece of paper. So even if you don't have a laptop, uh, not let that not stop you from learning how to code. So we'll release the application and then people can apply. Our target is 500 students for the course. So people can apply, and then we'll keep on admitting as more students, until all spots are filled. So it doesn't matter whether you are in Zimbabwe or you're in the US or you are in any other parts of sub-Saharan Africa. Of course, I'll first start by giving maybe priority to Zimbabweans first, and then I'll then extend it to fill the spots with other people if Zimbabweans they don't fill the 500 spots. But just encourage people if you know people who want to learn how to code, and the entire course is free. It's free, so you don't have to pay anything. Just come with your brain and be willing to learn. And we have an entire team of dedicated staff. Some of them were students that took the course the past 2 years, who will be there to help you also understand programming. So the way of teaching basically is just the same way of teaching that you can find at Harvard, that you can find at Stanford, that you can find at MIT, or you can find at UC Berkeley. So you are just lucky that you're just taking that same way of teaching, that same uh, enthusiasm, and we're just bringing it to you in a more innovative way. So for future, there are more M's in work programs, for example, which you have to follow after. But we also give like resume building support. We connect students to give them support, for example, for internships and full-time opportunities. We prepare people with mock interviews, behavioral and case studies. Maybe let's say you're applying for a consulting position or you're applying for a technical position. So we groom you, and we also teach more classes on like computer science or JavaScript, web design, app development, and mathematics. And we also partner with institutions to deliver lessons. So, for example, if it's a school or it's the club or something, as long as people can be mobilized into a group, that can be reasonable enough for us to set aside our time. We'll be there to like help everyone learn how to code. So M's in word code, like M's in it just means like home of code. So we envision like having Zimbabwe, having that part of Southern Africa as the stronghold when it comes to writing code and computer science. I think I am done with my presentation. So I have some pictures which we took from the first class. I'll just go through them within like just 10 seconds, and some additional pictures were in partnership with a program by Yolanda called Girls in Robotics, and the photos were taken by Brian Jahales and Zislanda. So here were some of our lessons where we're learning how to code. We were really enjoying how to code. Yeah, and this was quite, we're working on a project building a game similar to Plants vs. Zombies. And then these were the first cohort of students solving their problems. These were students in Girls in Robotics who were building robots. I think Form 3 girls and lower 6 girls who were building robots. So they're working on them. They're really enjoying technology is fun. And yeah, so I think that's it for the day. Anyone with questions, I can check some in the chat, and also I can stop sharing.